Hey guys, and welcome to another video. And this is my very first video on my channel Online Science 2017, and it's a topic in IGCSE Physics Topic 1 Forces. So before we start, I want to draw your attention to this triangle here in the corner. I'm sure all of you are very familiar with the triangle. It divides speed, distance, and time. And now we're showing you guys the different equations that link speed, distance, and time up. So let me just change my color. So we know that speed. Oh god, that's terrible. I should actually just write it out. So, speed equals distance and I'm gonna draw a line here over time. Right. So this is one of the equations that this can lead to. Distance speed equals distance that you must know before you can understand anything about forces and we'll talk about in IGCSE physics is of course the one that links distance, speed, and time. And that one goes like this. Distance equals speed times time. Now this is the one that you can find by covering, for example, if you want to find distance, you just cover distance and you say, oh, it's speed times time. So yeah, because if you look at this line here means divide. Okay, this line here means divide. This line here. So everything else will be times. And the last and final equation that is really important in this topic, before we can get into the more decent stuff on forces, is the time one, which goes time equals distance over speed. So now, these are the three basic equations that you must know before we can go into any of the forces stuff. So, I'm gonna give it I'm gonna just like leave this on here so we can use this to deal with the equations in a moment. But before that, I would like to talk about something called velocity. 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 And you're thinking, well, velocity sounds like something like speed, but no. The definition of velocity is velocity means the speed of something and its direction of travel. So this is the definition of velocity. Velocity means the speed of something and its direction of travel. Now, an example would be, if I was to write this out, let's say 10 meters per second. Alright? So we'll do the deal about, if we were to talk about this, for example, and we do it in a diagram, it will look something like this. So an arrow, basically, in this direction. So know that this is moving to the right. It's very hard writing with a mouse. Not saying. So then we went to the right, and we write in the here 10 m/s. Now, if I was to write an arrow, draw an arrow that looked a bit something like this about here. This will be going to the left. To the left. Right? This is going to the left. But this will not be a positive. Oh yeah, and that brings me. And speaking of that, I'm going to bring your attention to a brand new term that I believe now that is in this topic, and it's called vectors and scalars. Right, vectors and scalars. And you might think, so what does that even mean? Well, I'll tell you what it means. In this case of this arrow here, I just made a vector. But what does a vector even mean? Well, I'll tell you. A vector literally means something with a magnitude and a direction. A magnitude and a direction. So let me just type it up for you guys. Let me just erase this first. Right. So a vector literally means, I'll type this up for you guys as well. A vector means some magnitude and a direction. So a vector means a magnitude and a direction. So an example of that would be, let's say this is the floor. Oops. Right. Let's say this is the floor over here, and there's a brick on here, and I lift this brick and I move it that way 5 centimeters. So I move this brick 5 centimeters over there. Now we need to be able to know what direction it is moving, and we know this one is moving to the right. And that brings me on to my second point, which I'm drawing you 2 lines, which means an axis. So these lines, when you go up, it's positive. When you go to the right, it's positive. When you go to the left, it's negative, and when you're below, it's negative as well. So in this case, because it's moving 5 cm to the right, this will be positive 5. So it'll be just 5. Oh, sorry about that. I can be DC that, can you? So in this case, it'll be 5 cm to the right. To the right. So I move this brick 5 cm to the right. And let me give you another example. So let's say the green here. That I'm just gonna draw an arrow. I'm not picture anything. I'm gonna draw an arrow that goes like this. Now, and let's say this arrow is 6 centimeters. Now, to depend whether it's a negative or positive, you need to look at the direction. I mean that this is going up, so up is a positive. And it's going to the right, so it's also a positive. So in this case, this arrow would be positive 6 centimeters. Up, you always write the first one first, to the right. Right. So I'm not supposed to write on this document, but I'm going to do another video after this one on to continue on this and talk about scalars, and then we'll go into more detail about other stuff. So basically before then, happy learning, and I'll see you in class. Bye.